Problem 13 is guaranteed to cause you struggles, and so we're going to talk about problem number 13 right now because it's a very important problem. That's probably the reason why it's being asked. It's asking you to do something we haven't had to do before. It's going to tell you something cute and clever that's going to make your life better, but in the meantime, we have to make our lives miserable to see it. And so here we are approaching the miserable to see it portion of our program. When we look up here, we can see these two functions. They're written incorrectly, and I want to find the area between the two curves. So I'm going to quickly change out my equations so that they are rational in the way I want them to be, which is going to be y equals, right? So I end up by first thing I'm going to do is get x minus 4 equals y squared, because I need it in terms of y equals, and that's how we do these problems. Then I get that's going to become plus or minus the square root of x minus 4 equals y. And I look at this and go, oh dear Lord, what is this? Well, if we remember correctly, the reason why they're doing a plus or minus is because a square root function actually looks like this, right? And so it can't possibly tell you what the function is with just one thing. And so the plus case is this top curve, and the bottom case is the bottom curve, okay? And so you're like, well, okay, hopefully that doesn't matter. It turns out it does. And so this is the minus case down here. So this is the minus case there, and then the top one is going to be the plus case, okay? And I just use top and bottom, that should make you uncomfortable, make you start thinking, oh gosh, how would I do this problem? Before we do that, though, we don't have to panic yet, because the second equation, we need to solve that for y as well. And I get y equals x plus 2 by shuffling the 2 over from there. Okay, so these are my two functions. As we know, the square root bar is a horrible thing, so we're going to change that out for a, oh, I forgot to move the minus over. I keep thinking about that minus. So there's a minus for the x squared, so that makes this a negative and this a plus. Please don't miss that, because it makes our life even more miserable for this problem, and we want to be miserable here. Miserable is what we're looking for, so we pay attention when we get a better way to do the problem. Okay, so I look that over and go, all right, fine, I can do it. So now there's a problem here. The top graph changes right here. The top graph changes from this type of graph to this type of graph here. So I'm just going to do the first part. I'm going to note that this point right here, when I plug in, looks like -5, so I plugged a -5 in there earlier. I get -5, and then when I get a -5 in there for x, I get a -3 for y. I put a -5 here. I need a -3 for y to solve the bottom one. And the same thing works for the top one, so that works. This point right here, for future reference, is going to be the point 0, 2. This point here, by the way, which we don't need right away, is going to be 4, 0. And so I know I can integrate at least from -5 to 0, because I know how to do that. That's going to be the, so I start off by going, the area of this thing is going to be equal to the top curve, which is the line. So I'm going to integrate the line equation, which is x plus 2, and that doesn't look too bad. From x equals -5 to x equals 0 dx. Minus, and then I got to do from -5 to 0, and then I've got this ugly thing. Now I'm doing the bottom curve. The bottom curve we agreed was the negative curve, or at least I told you that, and I hope you remember that. So this is going to be negative, and it's going to be -x plus 4 to the 1/2 power dx. All right. So starting over here, I start to clean up my mess, hopefully. If I clean up my mess, I'm going to get that this is x squared over 2 plus 2x from -5 to 0. And then I got a minus sign here, a minus sign here. That makes a plus, okay? And then I've got to deal with this mess. So I look at this mess and go, all right, well, u equals -x plus 4. So du has to equal -1 dx. Agreed? And so I need a -1 here. I put another -1 out here. And so I've got this massive catastrophe of negatives. I've got a negative, 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 which makes me back to negative land. The integral from -5 to 0 of -x plus 4 to the 1/2 power times -1 dx. Okay, so now I've got it all ready to be U'd. I'm going to go ahead and U that, but first I'm going to solve this thing, so I'm going to start drifting this way because I need more room, obviously. So I plug in a 0 plus 0 minus, plug in my negative 5, I get 25 halves minus 10. All right, and then minus, and now I'm going to start this mess, and I'm going to realize, oh, I got a u substitution, so this becomes u to the 1/2 power du. That looks much better than my life was a second ago. But now I've got this other thing. We're going to negative 5 and a 0. And I got to plug in my negative 5, plug in negative 5 right here. And I get the bottom bound is going to be 9. I plug in my 4. Sorry, I plug in my 0. I plug in 0 here. I get to get 4 up here. Makes sense? And so cleaning this up, this left-hand side just becomes 5 halves. Hopefully you can do some fractionage. You know that this is going to be negative 20 halves, and so you end up with 5 halves. Hold on a second. Does that end up being negative? Yep, that ends up being negative. So I messed that up. So I'm glad I went back and checked that, because this is an awful problem to have to do twice. All right, so with that in mind, I'm going to go ahead and erase that, give myself a little more room, because we're going to probably need it, unfortunately. All right, so now I'm going to get my brush back up here. All right, so then I've got, so then I'm going to go whoop, and I'm going to go raise this power to the 3/2 power, put it 2/3 out in front, and then we've got it from 9 to 4. And so this becomes negative 5 halves minus, and then I'm going to throw a 4 in here. Okay, so 4, square root of 4, because that's what the 2 on the bottom does, gives me 2. 2 to the 3rd is 8, so this becomes 16 thirds. Minus, now I'm going to plug a 9 in here. 9 squared root of 9 is 3. 3 to the 3rd is 27, so I get 54 thirds. And then, therefore, I'm going to get negative 5 halves minus, I note that I end up with negative 38 thirds here, I believe. Yep, I think that's sufficient. And then minus and negative makes that positive. So I end up with negative 5 halves plus 38 thirds. I do a little witchcraft here, and I'm going to get negative 15 plus 76. Is that right? Looks like that's right. 76 over 6, and I get 61/6. All right. Whew! But we're not even done yet, are we? Because we've just done the area of this section over here. We haven't even done this side over here, which is ridiculous talk. How can we possibly finish this problem? It's ridiculous. Well, let's just keep going, because we're crazy enough we can pull that off. I'm going to draw a little line here so that when I start writing over here, we don't end up running over our own stuff. All right. So here we go. So I'm going to do this right-hand side. Now, the right-hand side I recognize the top part of the graph is the positive, the bottom half is the negative. So this is going to be the plus square root version, and this is going to be the minus square root version. So I'm going, oh gosh, how would I remember to do that? Yeah, this is a pain in the neck. This is a tough problem, right? So the area that the section on the right-hand side is going to be the integral from, now we're doing slightly on the x-axis, so we're going to start at 0, we're going to end at 4, and we're going to do the negative x plus 4 to the 1/2 power dx minus, parentheses, 0 to 4, negative, the negative being the bottom part of the graph. Now we're talking about the bottom part of that graph. Negative x plus 4 to the 1/2 power dx. And at this point, something interesting happens. You look at this and go, wait a second. If I got a negative here and a negative here, that's actually a plus, right? That's a plus. And if that's a plus, then these two are exactly the same integrals. Why are they the same? Well, because the area above the curve and the area below the curve, these are the same, right? So essentially, you could just have done 2 times the top curve, all right? You can just do 2 times the top curve, or you can do the top curve minus the bottom curve, which is going to do the exact same thing, right? Because these are going to be the same value. So because they're going to be the same value, I'm going to move forward and just go to integral from 0 to 4 of negative x plus 4 to the 1/2 dx. Oh, what will I set u equal to? Hey, it's right here. We've already done this before, so this becomes negative. I need a negative out front, so I throw a negative out front. 0 to 4, negative x plus 4 to the 1/2 power dx. So I need a negative 1 in here, because that's why I put a negative out front, so I can change my thing to a du. I'm ready to du it, so I'm going to change my bounds at the same time. I plug a 0 into this function, and I get 4. I plug a 4 in this function and I get 0. And I get u to the 1/2 du. Aren't we having fun? So therefore, raise its power by 1, divide by the power I get. Remember, I still got a -2 out front, and I got a 4 to 0. Plug in a 0. Plug in a 0, I get 0. Plug in a 4 minus a -4/3. That's the 2 times 2/3. If I plug a 4 in there, the square root of 4 is 2. 2 to the 3rd is 8. So this becomes 8, right? And so then with a little bit of flash and magic, I get that this is going to be 32/3, which since I want to add it to sixths, I would get 64/4, which is 64/6, which is therefore 125/6. And congratulations, you've just done this problem. And it's a wonderful thing. Isn't this exciting? Right? Now pause this. Make sure you can grind your way through this. Make sure you understand whatever logic you have. And then unpause this and see the real way to do this problem. So the real way to do this problem is to go, look, x and y are just variables, right? I could actually literally change this to an x squared and change that to an x and change these to y and this to y. I'd have to get the same area, right? It just would be drawn differently. It would be drawn such that if I switch this with an x, I'd have a y -2 intercept, so I'd have a line like this, and I'd have a curve of some sort above this, and I'd be able to shade this whole thing in, and I'd be able to do this in a heartbeat, and just by changing x's and y's. So we're going to essentially do that. We're going to do that the official way, which is instead of changing it into y equals, we're going to use everything in terms of x equals. And so which one has a higher value of x? Well, I look at the two curves. This has a higher value of x. And so I'm going to integrate the higher one, 4 minus y squared dy now, because we're going to slide along this axis instead. And because we're sliding along that axis, and then we're going to do minus, and then since this has a lower value of x, I'm going to integrate from y minus 2 dy. And I'm going to integrate from where y equals to y equals. We know y ends at 2 because we looked at that point earlier. And I believe, if I did the math correctly, this is going to be -3 down here. So since that's -3 down here, now I'm ready to do the problem, right? I can whip my way right through this problem. I get 4y minus y to the 3rd over 3 from -3 to 2. Kind of don't want the lag I'm getting. Y squared minus 2y from -3 to 2. Plug in my 2, I get 8, minus plug in my 2, I get 8/3, minus plug in my -3, I get -12, 27, so this goes plus 9, minus plug in my 2, I get 4, oops, I didn't divide by 2, so I get 2, and then I get minus 4, minus parentheses, and I've got plug in a -3, I get 9/2. Plug in a -3, I get plus 6. And then I've got that going. And then I've got 24/3 minus 8/3 plus 3 minus parentheses -2 minus 12/21/2. And doing my math fast because I got another minute before this thing shuts it down. I get 16/3 plus 3 minus parentheses. I get 4/25 minus 25 I'm going to turn everything to 6 because I have a 2 and a 3 on the bottom. So I'm going to get 32/6 plus 18/6 plus 75/6, and looky here, I get 125/6. And so that is the faster way to do the problem, simply changing x and y. And that is why for so long we've been talking about you have to write your dx or your dt, or because you can choose to do this problem as a dx problem or a dy problem. And that is one of the ideas we're introducing in this chapter. All right. Yeah, so questions, whatever, send me notes and send me by email or send it by dropping things into Teams.